So what is factorization? Let's discuss about this today. Any polynomial of the ninth degree may be written as fx is equal to a0 x to the power n plus a1 x to the power n minus 1 plus dot dot a n minus 1 x plus an, where a0 is not equal to 0, where ais are real numbers. This is a polynomial in one variable, but we need to simplify the given polynomial so that we need to find out the factors of it. From the knowledge of the quadratic equation, we know that if alpha be a root of the quadratic equation ax square plus bx plus c is equal to 0, then ax square plus bx plus c is equal to 0 has one factor, that is x minus alpha. Same idea is applicable for any n degree polynomial. To find the exact roots of the polynomial equation, we need factorization. For example, x square minus 9x plus 90 is equal to x minus 4 into x minus 5. So this polynomial have two factors, x minus 4 and x minus 5. Now let's get to the basics of the factorization. From our 5th or 6th standard mathematics, we know that for any two numbers, dividend is equal to the divisor into quotient plus the remainder. Same rule is applicable for any two polynomials. If fx is divided by a non-zero polynomial, say gx, then there exist two polynomials qx and rx such that fx is equal to gx into qx plus rx, where degree of rx is either 0 or less than that of gx. A non-zero polynomial gx is called a factor of the polynomial fx if there exists some polynomial qx such that fx is equal to gx into qx. Now let's talk about the useful results. Factor theorem: if fx is a given polynomial and a be any real number, then x minus a is a factor of fx if fa is equal to 0, and conversely, that is r is equal to 0. Now the remainder theorem says if the given polynomial fx is divided by the factor x minus c, where c is any real number, then the remainder is equal to fc, that is fx is equal to x minus c into qx plus r, then fc is equal to r. Now let's discuss a few problems. It says that find the remainder when the polynomial fx is equal to x cubed minus 3x minus 1 when it is divided by x minus 5. So the solution will be using the remainder theorem. Remainder is equal to f5, which is equal to f to the power 3 minus 3 into 5 minus 1, which means 125 minus 15 minus 1, which gives 109 as the answer. Now another problem says that factorize the x cubed plus x square minus 4x minus 5. So by the solution, we know that by the trial and error, we want to find some factor. Clearly 0, 1 do not satisfy this polynomial. f0 is equal to minus 4, which is not equal to 0, and f1 is equal to 2 minus 8, which is minus 6, and that is also not equal to 0. But f minus 1 is equal to minus 1 to the power 3 plus minus 1 to the power 2 minus 4 into minus 1 minus 4 is equal to minus 1 plus 4 minus 4 is equal to 0. So x plus 1 is a factor. Then fx is equal to x cubed plus x square minus 4x minus 4 is equal to x plus 1 into x square minus 4, which is equal to x plus 1 into x plus 2 into x minus 2, the required factorization. Let's move on to problem number 3. Show that x minus 1 is a factor of the polynomial x cubed minus x square plus 11x minus 6 and hence factorized. So by solution we can write now that if 1 is equal to 1 cube minus 6 into 1 to the power 2 plus 11 into 1 minus 6, which gives the result 1 minus 6 plus 11 minus 6, which means 12 minus 12 is equal to 0. So x minus 1 is a factor of the polynomial. Therefore fx is equal to x cubed minus 6x square plus 11x minus 6 is equal to x minus 1 into x square minus 5x plus 6 is equal to x minus 1 into x minus 2 into x minus 3. Another problem says find the value of k for which x minus k is a factor of fx is equal to x to the power 4 minus kx to the power cube minus x plus 7. So by the solution you can write here fk is equal to 0, so k to the power 4 minus k into k to the power 3 minus k plus 7 is equal to 0, which means minus k plus 7 is equal to 0. Hence it implies that k is equal to 7. Another problem asks for check whether x minus 1 is a factor of if x is equal to x to the power 5 minus x to the power 4 plus x cube minus x square plus x minus 1. So by the solution you can write f1 is equal to 1 to the power 5 minus 1 to the power 4 plus 1 to the power 3 minus 1 square plus 1 minus 1, which equals to 0. So you can know that x minus 1 is a factor of the polynomial fx. Another problem is given. It says which numbers should be subtracted from the polynomial x cube plus 3x square minus 8x plus 14, so that on dividing it by x minus 2 we will get 10 as the remainder. So let's see that it should be subtracted from the given polynomial, and let fx is equal to x cube plus 3x square minus 8x plus 14 minus c. Then by the remainder theorem we know that f2 is equal to 10. So 2 to the power 3 plus 3 into 2 to the power 2 minus 8 into 2 plus 14 minus c gives 10, which means 8 plus 12 minus 16 plus 14 minus c is equal to 10. Which implies 18 minus c is equal to 10, or c is equal to 8. I hope these problems are clear to you all. Now let's move on to the another problem. If x plus 2 and x minus 3 are the two factors of the polynomial x cubed plus ax plus b, then find the values of a, b, and hence factorize. So by solution you know that let fx is equal to x cubed plus ax plus b. Since x plus 2 is a factor, the remainder is equal to f minus 2, which is equal to 0, that is minus 2 to the power 3 plus a into minus 2 plus b is equal to 0, or minus 8 minus 2a plus b is equal to 0, which means minus 2a plus b is equal to 8. This is the first equation. Similarly, x minus 3 is also a factor, so f3 is equal to 0. Therefore, 3 to the power 3 plus a into 3 plus b is equal to 0, or you can also write 27 plus 3a plus b is equal to 0, which means the second equation is 3a plus b is equal to minus 27. Hence, solving 1 and 2, we have 5a is equal to minus 35, or a is equal to minus 7. Then after putting the values, b is equal to 8 plus 2 into minus 7, which is equal to 8 minus 14, which is minus 6, and fx is equal to x cubed minus 7x minus 6, which is equal to x plus 1 into x square minus x minus 6, which means x plus 1 into x plus 2 into x minus 3. I hope factorization chapter is clear to you all. So thank you for watching this video, and if you have any queries, you can write it down in the comment box.